slew rate. The slew rate decides the capability of an op amp to change its output rapidly. Therefore, it decides the highest frequency of operation for the op amp. That is, the slew rate limits the performance of a circuit limits the performance of a circuit and distorts the output waveform. The units for the slew rate are, it's actually the units of voltage per unit time, and it's typically measured in volts per microseconds. The slew rate of the 741 is max of 0.5 volts per microseconds. As we will see in lab 7, to measure the slew rate, one inputs a square wave, a square voltage waveform, and simultaneously on another channel, we'll simultaneously look at the output. So in other words, on the scope, let's say in channel 1, we're going to have the input, and on channel 2, we're going to have the output so that we could compare them. And then we're going to superimpose them. So picture-wise, suppose an AC square wave is the input into the op amp. So if we use a voltage follower, we're going to find that it's going to do something like this. So let's say here, so let's break this up into two situations. So let's say that if the frequency is below SR max, and in this case, that would be 0.5 volt per microsecond, the output waveform looks identical to the input waveform. So picture-wise, I'm going to imagine something like this. So let's say that on channel 1, we're looking at the input. So let's say that I have a square wave like this. And it just keeps going on and on and on. So we're going to say that this guy is our input. So the square wave turns on and turns off. So here's what we're going to say is that this here is our square wave input. So what we're going to do on another channel, we're going to look at the output. And if it's below the threshold, then that means when I go and I look at this guy, it looks exactly the same. And so if I'm looking at this, we can see here that these guys look identical, but they are two different waves. And again, this is when we're looking at using a voltage follower. So in this situation, this is our square wave output. Now, something changes here. If the frequency of the input square wave exceeds the max slew rate, the output waveform is distorted. I don't know if distorted is the right word, but that's the word I'm going to use. So for now, if I come in here and I grab this guy, because I'm putting the exact same square wave, but now it's at a higher frequency. So if I'm looking at this thing, then look what happens now. So if I follow this guy all the way down, what actually happens now? The waveform can't keep up. So there is a lag. and then it changes, but there it can't change fast enough. And so it's not square anymore. It's looking like this here. So this is the square wave output is limited by the slew rate. And you can see how that wave is now not the same. And that's it for the slew rate.